In today's video, I am going to talk about contact angle and wettability. A contact angle gives us an indication of how well or how poorly a liquid will spread over a surface. While formulating coating, inks or paints, contact angle provides a useful indication of how a modification to the ink or paint will affect its spreading over the solid surface. It also gives a strong indication on the performance of the product as well as successfulness of the process. Basically, contact angle expresses how a liquid interacts with a solid surface. Suppose we have a solid surface and we put a drop of liquid on it. We can determine the level of interaction between solid and liquid with this angle theta, which is known as contact angle. Now, there can be several possibilities of how the liquid drop interacts with the solid surface. We might have a drop that looks like a ball where the contact angle is 180 degree. In this case, we have something that is completely non-wetting. Wetting is the ability of a liquid to maintain contact with a solid surface. Wettability is inverse of the contact angle. That means higher the contact angle, lower is the wettability. So, non-wetting means liquid will stay on the solid surface in droplet form. It will not spread on the surface. As we can see here, the liquid droplet can easily roll over the surface due to poor wettability and high contact angle. Whereas in another situation, we can also have a drop spread out completely and cover the surface. In this case, contact angle is 0 degree and this would be perfect wetting or complete wetting. So, in case of perfect wetting, we have theta that is equal to 0 degree, whereas in case of perfect non-wetting, theta is 180 degree. But in most cases, we have something in between these two, where theta is between 0 and 180 degree. So, 90 degree is the angle where two phases show either wetting or non-wetting. So, if the contact angle between the liquid drop and solid surface is less than 90 degree, it is called wetting, and if it's higher than 90 degree, then it is called non-wetting. If taken liquid is water and contact angle is less than 90 degree, the surface is hydrophilic, and if the contact angle is greater than 90 degree, then surface is hydrophobic. If the contact angle is close to theoretical limit of 180 degree, then the surface is considered superhydrophobic. A contact angle can be large or small depending on the physical properties of material being investigated, such as nature of liquid, type of solid surface, etc. An example of surface that is non-wetting is the lotus leaf, which is shown here. We can see that contact angle between water droplet and lotus leaf is much higher than 90 degree, and water droplets form nearly spherical shape. On the other hand, if we drop water on the cotton fabric, water forms zero contact angle with cotton fabric and spreads out completely, showing complete wetting. So, what could be the reason that the water does not spread out on all the solid surfaces and remain in spherical droplet form? To understand this, first we need to understand surface tension. Let's take example of water droplet. Due to surface tension, water or any other liquid forms spherical shape. It is because water molecules in the liquid are attracted to each other. These water molecules can form hydrogen bonding with other water molecules around them. So the fact that water and other liquid molecules are attracted to each other is known as cohesion, and this attractive force is known as cohesive force. Since these water molecules likes to bunch together or form groups, but due to cohesive force, a molecule is pulled equally in all directions by neighboring molecules. This results in a net force of 0. However, at the surface there is no water molecule above them. These are less restricted and are in a state of higher energy compared to the molecule in the bulk of the liquid. This allows surface molecules to group together a little better and form a stronger, tighter bond in such a way that they form a tension that is not present in water molecules below the surface. These bulk water molecules down below will prevent surface molecules from grouping by pulling the molecules toward the center. Since the force is only working downward and sidewise, the liquid forms a spherical shape. So, basically surface tension is the tendency of a liquid surface to shrink into minimum surface area possible. Because of that, liquid molecules are able to make or maintain spherical shape. Now, if we have two liquids having high and low surface tension, high surface tension liquid will form high contact angle or large contact angle and will stay in spherical droplet form, whereas low surface tension liquid will have low contact angle compared to high surface tension liquid and will show tendency of wetting. That means this will spread out on the solid surface. Now coming back to contact angle. So fundamentally contact angles are a function of the interaction of the surface tension involved. There are three boundaries to consider when a liquid droplet is in contact with a solid surface: the solid, the liquid, and the vapor surrounding them, which is usually air. As we can see that we have surface tension of liquid against vapor. We have surface tension, or we can say surface energy, which is an accurate term to represent surface tension of solid against vapor. And finally surface tension of liquid against solid. The figure shown here is a force diagram of the point where all three phases meet. The three arrows represents the force exerted by the surface tension at three interfaces: liquid solid, liquid vapor, and solid vapor. Each force is pulling away from the equilibrium point. So, if the droplet is in equilibrium, then the forces are balanced. That means leftward force is going to be equal to rightward force. So, the surface tension of solid vapor is going to be equal to liquid vapor plus liquid solid cos theta. So, cos theta is equal to difference in surface tension of solid vapor minus liquid solid divided by liquid vapor. Now, you might have questioned that are surface energy and surface tension equal? So, numerically in SI system, surface energy and surface tension are equal. Both have same unit. Surface tension exists when liquid gas, oil water or gas water phases are present. Whereas surface energy is a key property of a solid which tells about wettability of that solid surface. So, if we know surface tension and surface energy, we can calculate contact angle. These are the ideal situations where solid surface is smooth and liquid is pure. But this is not the case always. There are some factors such as surface roughness, impurities, functional groups on the surface, etc. that affect contact angle. In our next video, we will discuss factors that affect contact angle. I hope you enjoyed today's video. If you liked the video, please subscribe to our channel Polymer World. Thank you.